this assessment, we're ranking the compounds shown based on their ability to participate in an SN1 reaction. Note that the SN1 reaction starts with the formation of a carbocation. In each of these 5 molecules, the carbocation that would be produced would be a secondary carbocation. So what this question is really asking us to do is to rank these based on their leaving group ability. And so I've drawn the 5 leaving groups in each of these reactions. To understand leaving group ability, we can look at the pKa of the conjugate acid of these leaving groups. So for example, for the carboxylic acid, that's going to have a pKa of 5. HBr is going to have a pKa of -8. H3O plus, -1.7. HCl, -7. And the pK of water is 16. With water having the highest pKa, that tells us that the hydroxide is the strongest or most unstable base. That means it is the worst leaving group. So we automatically will expect this to be compound 5, the least reactive or the least likely to undergo an SN1 reaction. On the other end of the spectrum is HBr and HCl, both very strong acids, implying that Br- and Cl- are going to be excellent leaving groups. Since we're doing an SN1 reaction, we'll assume that we're going to be in a protic solvent, in which case chloride in a protic solvent is going to be a slightly better leaving group than bromide in the protic solvent. So this one will be number 1, the bromide, one with the bromine leaving group. The bromide leaving group will be 2. We can then look at water as a leaving group when we compare it to H3O plus, a pKa of -1.7. It will end up being the 3rd, and the acetate, whose acetic acid has a pKa of 5, will end up being in 4th place. So the best, most likely to do SN1, the alkyl halides, followed by water as a leaving group, followed by acetate, and then hydroxide.